When we have an absolute value inequality, we're going to have an absolute value with an inequality. In order to solve for x, we need to undo this absolute value. To undo the absolute value, we're going to take the quantity inside of the absolute value, 2x plus 7, and compare it to 11. Well, the first comparison is going to be 2x plus 7 has to be less than 11. And our other comparison, we're going to take the quantity 2x plus 7 and compare it to the opposite of 11. The opposite of 11 is negative 11. And if you remember, the one rule when working with inequalities is if we multiply by a negative or divide by a negative, we need to switch the sign. Well, we're going to have to do the same thing when working with absolute value inequalities. Really, what's happening is we're comparing 2x plus 7 to the opposite of 11. So we need to make sure that we have the opposite sign. Instead of a less than, we need a greater than. Once we have the two inequalities set up, we can solve for x. To graph my solution, I'm going to create a number line. And my two critical values are 2, I'm going to put an open dot at 2, and negative 9. I'm going to put an open dot at negative 9. Now I want to include all the points that are less than 2. Well, the points less than 2 are to the left of this dot. And I also want to include all the points for x that are greater than negative 9. So I want to include all the points greater than negative 9. Well, if you look, if I go to the right of negative 9 and I go to the left of 2, I'm going to be shading all of the points between those two dots. So this is really an AND compound inequality. I want all of the values that are between negative 9 and 2. So 2 has to be greater than x, and negative 9 has to be less than x. So I could write these two inequalities as one inequality. To remember that this is an AND inequality, I'm going to look back at the original. I have a less than symbol. Think of less than as less than. If I think of this as less than, when I set up my two inequalities, I'm going to need an AND. In the second example, I'm going to take the quantity inside the absolute value, 3x minus 2, and first compare it to 8. And the way I want to compare it to 8 is it has to be greater than or equal to 8. Then I'm going to take the quantity inside the absolute value and compare it to the opposite of 8. The opposite of 8 is negative 8. And again, when I change this to the opposite, I'm going to want to change my inequality to the opposite. Now I can solve for x. At this point, I'm going to want to graph my solution. So I'm going to draw in a number line. My critical values are at 10/3 and negative 2. 10/3 is 3 and 1/3. So I'm going to put a dot at 3 and 1/3. And this time I'm going to make it a solid dot. And then I'm going to put a dot at negative 2. And again, I'm going to make it a solid dot because I want to include negative 2 and 10/3 in my solution. Now I want all the x values that are greater than or equal to 10/3. So I want all the x values that are greater than 10/3 to the right of 10/3. So I'm going to shade to the right. And I want all the x values less than negative 2, so I'm going to shade to the left of negative 2. Now if I look, this is really an OR inequality. My solutions are either here or here. To remember that, think of this symbol as a greater than symbol, a greater symbol. Whenever you have an absolute value and a greater symbol, set up two inequalities, and we're going to have an OR compound inequality.